Yeah, thank you. So flexural shear flow is what again? It is again Q equal to tau into T. But what is this tau? This tau is what? Flexural shear stress. Flexural shear stress. Now guys, this flexural shear stress is due to what? Non-uniform bending or due to shear forces. Clear? Now guys, we already know what is the bending stress formula, which is for unsymmetrical bending in case of thin wall structure. It is what? Sigma z equal to k1x plus k2y, and we know k1 and k2 value, which are you guys can see here. And so once you know this, then suppose your sigma z is varying. Why it will be varying? Due to non-uniform bending. If sigma z is varying, you can see take a cantilever beam, right? And you know your moment will be varying, right? From free end towards fixed end. So if your moment is varying at any section, if you take your sigma z will be varying, okay, at a particular distance from neutral axis. Now guys, when sigma z is varying, so we consider this is a thin walled section, and this is what the element. Now you can see here it is sigma z, and variation of sigma z along z direction is given by Taylor series expansion, which is what? Sigma z plus dou sigma z by dou z into dz over what length changing and how it is changing, then initial value plus that change into total length. Okay, same way, suppose my flow on this side it is q, and this coordinate we know already, the curved coordinate we consider as, so you know it will be what? Q plus dou q by dou s into ds. Okay, so this is what the variation. Okay, here it is ds. Now guys, if you take force equilibrium in z direction, what we get? Sigma z into ds into t minus this, then q into dz. Guys, why t is not there? Can anyone tell why here t is not there? Why t is not there here? Why t is not there? See, you guys can see what is the force. This is force per unit length into this length, which is dz. Okay, so you can see it is what? Q into dz. Then minus, why? Because one in positive z direction and another is in negative z direction. So we can see this equilibrium. From this equilibrium, what we find? This equation. Dou q by to dou sigma by dou z equal to 0. Now what is the sigma, guys? This sigma z, actually it is sigma z. So what is the sigma z? We already know. When we substitute the sigma z in this equation, so you can find dou q by dou s, the rate of change of shear flow along s direction. How it is given? Minus t. Then see in sigma z, what is the variable quantity? What is the variable quantity? In k1x plus k2y. So in k1 and k2, what is the variable? What is the variable? What is the k1? It is myixx minus mxixy. So what is the variable in this? Guys, please keep responding. What is the variable? The moment is variable, right? That's what we are talking, non-uniform moment. So when variable, this is constant. So which thing will be differentiated? Moment. So you can see dou my by dou z and you dou mx by dou z. So same thing in second K2 part, this. Now guys, you guys have to understand one thing. What is this rate of change of moment? Can anyone tell? We have derived, right, in shear force bending moment diagram. in that case, what we derived, V equal to dm by dx, right? Not Q. V equal to dm by dx. Okay. In that case, what we did, we taken x is the longitudinal axis. It's a shear force, right? And what was your cross section? Our cross section was y and z. Okay. So guys, if you see this, what we see in our case, sigma x was what? It was mz upon iz into y. Okay. Or other way around, you can say, if you take z axis, let's take z is the longitudinal axis. This is y, this is z. So what will the cross section? My cross section will be x and y. Now guys, what is your sigma z? Simple bending. It will be mx upon ix into y, right? Now what is this vertical direction? What will be the shear force? Shear force will be Vy. Vy will be what? Dmx upon dz. Everyone, is it clear? Dmx upon dz is what? Vy. So you can see, same way, if you have another term, complex bending, right? So another term will be what? It will be my upon iy into x. So that means your Vx will be what? My shear force in x direction will be what? It will be dou my by dou z. Am I making sense? Is this point clear? How this Vx and Vy? Everybody, is it clear? Yeah. See, you all know, right? When I discuss this beam, I told, suppose this is your x and let's take this is y, right? So you can have two moments, right? One is mx and then my, right? So if your mx is varying, what shear force you will get? You will get Vy will be dou mx by dou z. Now guys, this my, if my is varying, that means you can see the bending due to my is what? Is like this, right? So perpendicular to this is what? X-axis. So what is the Vx? It is dou my by dou z. Assis, is it clear? And in this case, you know what it was? Sigma z was mx upon ix into y plus my upon iy into x. Clear? So you can say you have mx and my. So if mx is varying, you will have shear force along y direction, and if your my is varying, you will have shear force along x direction. Clear? This point clear? Okay. Now guys, then substitute Vx and Vy, we get this equation. So this is what? This is shear flow, rate of change of shear flow, okay? And it is given by this big equation. Now suppose you want shear flow Qs. So what will be Qs? Qs will be dou Q by dou S into ds, and it need to be integrated. Okay? Shear flow in any section, it is what? Dou Q by dou S ds integration. Okay? So when you do integration, you can see you have x, y, and you need to integrate along ds direction. So when you substitute, you can see this equation like t and x. X can be taken inside because sometimes it may be varying, and y. So your equation, if you write here this Q, so my further if you write equation, it will be what? QS, and this is equal to minus T Ix Vx minus Vy into Ixy upon Ix into Iy minus Ixy square integration x ds, then minus T, then it is Iyy into Vy minus Ixy into Vx upon, okay, and integration y ds. Okay, so this is for a thin walled section, like you have a C section, thin walled section. Suppose guys, this thin walled section is idealized to lumped area. So in that case, what will be this QS formula? So what will happen in that case? This T into ds will become area. So this same equation further, if you want to write, see, we have written this QS, it was what? It is, if you write in this form, so it is Vx Ixx minus Vy Ixy upon Ixx Iyy minus Ixy square integration x tds. Let me write like this. Then second, Vy Iyy minus Vx Ixy upon Ixx Iyy minus Ixy square integration y tds. Okay, because sometime your T can be also varying. Okay, if you take Maxon book, there are several questions on flexural shear flow. In some question, your thickness is also varying. So this is formula for thin wall. Now suppose you have lumped area. So in that case, what it will equation will become? It will be minus Vx Ixx minus Vy Ixy upon Ix Iy minus Ixy square. Now this form, what will happen? This integral TDS will be A. So it will be like sigma AX minus, this will be Vy Iy y minus Vx Ixy upon Ixx Iyy minus Ixy square, then sigma sigma A y. Now from where x and y are measured, can anyone tell? From where x and y distances are measured? From where we measure? These will be measured from centroid, as neutral axis passes through centroid. Clear? Are this shear flow formula clear in any section? Flexural shear flow, anyone has any doubt? I went once for Airbus interview. They asked me this formula. Can you write the shear flow formula? Okay. So guys, if you work in aero structure, definitely all these are very important. Anyone has any doubt in this? Any question? So one request is there. Okay, so now we know the flexural shear flow. So let's start with one question. Okay, a C section. So this C section has dimensions like h, 2h, h, and thicknesses are t throughout. What I want first, I want to find first shear flow distribution diagram. For a load which is applied at shear center in vertical direction. Okay, and I don't know shear center position. Let's I am assuming, okay, with my own experience, this is my neutral axis. Okay, and This is exactly not neutral axis. You don't say neutral axis. This is the axis of symmetry. Okay, and here my shear center. I am assuming, okay, that I have to find out the position of shear center. Before that, I need to find the shear flow distribution. Okay, distribution for this channel section. Okay, channel section. Now guys, to do that, first thing, what is the shear flow formula? Okay, and this is one open section. You guys can see it's an open section. So your shear flow, you can see for thin wall section at free end, for open section, shear flow is considered to be 0. This is what the boundary condition. So at the open section, if you take open section means here and here, your shear flow will be 0. This is from boundary condition. Okay. Now guys, shear flow distribution. So we know what is the rate of change of shear flow. And shear flow at any section, QS is what? It is, again if I write minus, it is Vx Ix minus Vy Ixy upon Ix Iy minus Ixy square. Okay, then integration x t ds minus Vy Iy minus Vx Ixy upon Ix Iy minus Ixy square integration y t ds. Now if you see this given section, it is symmetric section, right? It is symmetric about what? This axis. Suppose this axis is x-axis. Yes or no? It is symmetric or not? Yes or no, guys? This C section is symmetric or not? It is symmetric, right? So that means what will be Ixy? It is 0. And in this case, what is the shear force? We have Vy alone, right? So what about Vx? It is 0. When Vx is 0, if you substitute in this equation, what we see, this completely will become 0. Why? Vx is 0, Ixy is 0. In this equation, this is 0. So finally, what is the QS? It will become minus Vy upon Ix integration YT ds. Clear? So now guys, tell me, is this tough? If you have a simplified equation, is it tough? If you know this is the easy equation, right, for channel section. Now guys, one more thing I will tell you. To find, see in this case, your shear center will definitely lie on x-axis, right? Because it's a symmetric about x-axis. So what is unknown position? See, or you can say it will is lying on x-axis. Okay, or you can say y position is 0, right? So what is unknown position? X position. So to find x position of shear center, actually I have not explained what is the shear center, that I will explain. Okay, just before that I will explain how to draw shear flow distribution and all. Okay, so to find the x position of shear center, okay, you require what? Only Vy force. Okay, if you just have shear force in vertical direction, you can find horizontal position of shear center. Now suppose my given section is like this. In this case, what is going to happen? now symmetric about y-axis. Okay, y-axis. So horizontal position will be 0. Okay, but yes, so next is shear center. So shear center is a cross-sectional property. What I mean by that? Anyone? What I mean? Yes, not dependent on material. Yes, it will also not depend on load. Getting my point? So shear center is a cross-sectional property, means it is independent of loads and material. Clear my point? It is independent of materials and loads. Okay, so let's see what is the shear center. Shear center is a point if transverse load is applied through this point, then there will be no twisting, only there will be bending. Okay, now guys, if you take simple square section or rectangle or circle, what happen if you find centroid? These are doubly symmetric section. So this centroid itself is what? Your shear center. What I mean, if you apply loads through this centroid, okay, what is going to happen? These section will just bend, right? Yes or no? There will be no twist. But suppose instead of here, if I apply my load here, what is going to happen? For this rectangular section, what is going to happen? Can anyone tell? You can take your beam is like this. Along with bending, what is going to happen? It will twist also, right? So it will bend, okay, and same way it will be twisting. Clear? So that means why it is twisting? Because this force is not passing through this point, which is called shear center. Is this point clear to everyone? So what is the shear center? Shear center is a point if transverse loads are applied through that points. In the section, there will be no twisting, it will only bend. Now guys, if you take channel section, now what is going to happen? You may see your centroid is here. Okay, your centroid is somewhere here. But we will see this centroid is not shear center. So that means in this case, if you apply load through centroid, will it not twist? It will twist. Why? Because for this shear center will be somewhere here. But you know this shear center is here. Can you apply in the reality load here in air? Because load has to pass through this section, right? Yes or no? Your load has to pass through this section, yes or no? You can apply load on structure, right? You cannot apply load in air. So that means what? If you use your C section, definitely it will bend as well as twist. You apply load anywhere. Because for channel section, your shear center will be outside section. So you guys see in many places your beam are I section, not C section. Clear na? Why these are I section, not C section? Why? For I section, we can make a symmetry, right? So your shear center and centroid will be same. Clear na? This point, guys? Or you can see some places you will see T section also. I will explain what is the advantage of having T section or L section also. Okay. Now guys, the next, this shear center is also the center of twist, or you can say it is also the point of twist or center of twist, okay, or center of flexure. Okay, so that means if you apply the twisting moment, the point which will not have any kind of movement, okay, the point which will not have any kind of movement, if you apply twist alone, that point is what? That point is shear center. So shear center is also the center of twist. Okay. Now shear center is a cross-sectional property, and anyway I told it is independent of loading. Now if you have any section which has a junction, so that junction itself will be shear center. So you guys know, right, which all section junction? You can see L section is a junction. Junction means what? The point at which two sections are coming and meeting, so it is junction. So this will be your shear center. Now if you take T section, I was talking, so in T section this is junction, so this is shear center. So what is the advantage of T section? Yes, we can apply load along this point, right? So that's why some places you will see T section is also used, okay, instead of C section. Now if you see V section, here junction, so shear center. If you see this section, so this is shear center. You can see this crossified or cross, so this will be what? Shear center. We will see why this is the shear center when we discuss, you know, this what we call this shear center calculation part. Okay, we'll see. So whenever there is a junction point, that point itself will be shear center. Now for doubly symmetric, already I discussed for like square section, circle, or rectangle, or I section. If it is a doubly symmetric, the centroid itself will be shear center. For single symmetry, of course, your shear center will lie on the axis of symmetry. Like C section is symmetric, so your shear center will lie on this axis of symmetry. Okay, so this is all about shear center. Yes, there are questions from this shear center. So if you see, this is one of the question which came in exam. For this thin walled beam cross section as shown in the figure, the shear center lies at, which is the correct answer? It's a slanted T section. So your junction B, which is like C here, will be what? Your shear center. Okay, so this also answer is wrong in some of the so-called Google key Hoshne. For this question also, you will find some people are writing G as a shear center. Now can you tell me, for this, since it's a junction point, okay, your shear, now what these dots represent? Can anyone tell what these dots represent? What these dots are representing? Can anyone tell? These are lumped area. Okay, so this is what idealized section. Don't get confused by that. Okay, and this G is different. This is not lumped area. this G is not lumped area. Okay, this is some point they are just representing, or you can say this completely is a thin wall section to represent these points they have dotted. Clear my point? Because there is not much clarity on this. Everyone, is it clear what these dots represent? They just to notify these points they have noted. Okay, that is the other way too, because G is not lumped area. If it is a lumped area, then it need to be connected with the section. Clear? Or somehow you can see maximum this can be like this kind of branch, then only I will say yes, this is the lumped area. So basically these all are the point. Okay, so why B is the shear center? Clear to everyone? Osne, is it clear this point? Yes, Ashish, tell me. Tell me, Ashish. Anything to tell? Okay, so let's move to next question. Yes, Ashish. That doesn't mean, see, it's not necessary for junction to be symmetric. We are not saying it is lying on axis of symmetry. For any junction, we are saying any section with junction, we are saying this junction itself is shear center. I'll explain why. See, if you draw shear flow distribution, all the shear flow will pass through this junction. So if you take the moment equivalence about this, it will come 0. Okay. So that junction point is why? Because all the shear flow of this T section will pass through that. So if you take the moment equivalence about point B, it will be 0. Okay. Okay, next question. Read the question, what it says. Consider 4 inward beam of different open cross section as shown in the cases 1 to 4. A shear force of magnitude F acts vertically downward at the location P in all the beams. In which of the following case does the shear force include shear force induced bending and twisting? Guys, read and tell me the answer.
B option.
Yeah. So in which case you see A is shear center, so it will have only bending. P, this is not shear center in case 2, so it will have both bending and twisting. If you say case 3, this is shear center, so you will not have any twisting. And if you take case 4, it is shear center, so you will not have any twisting. So what is the answer? B is the answer. B is the answer. Who told D? Is saying D is the answer. Is saying D is the answer, guys. Ashish, is the D is the answer? Okay, by mistake. No problem. Guys, just a moment, huh? Okay, I'll just come quickly. guys, I'll move back to that C section. Okay, channel section. So for channel section, as I told, we applied only shear force which is in y direction, and suppose this is what shear center, so it is Vy. Okay, and I have taken this is H, 2H. Okay, because now you need to solve the another gate question. Okay, so which is like shear center position they asked one time, and T is the thickness. For this, when we derived, we found what is the QS? It is minus Vy upon Ix integration Yt ds. Is it correct? This is what we got. Yes or no, guys? Now, guys, suppose this point 1 and 2, 3, 4. We know already from boundary condition Q1 is equal to Q4 is equal to what? From boundary condition, guys, what we know? Q1 equal to Q4 equal to 0. Okay. Now suppose I want for section 1 to 2. What is my shear flow distribution? 1 to 2. Because for C section there is one gate question in gate civil. In gate civil for channel section they asked how the shear flow look like for channel section. Okay, so they may ask in gate aerospace also. So we will see how to do this for section 1 to 2. So if you see this section 1 to 2, what is this y value? What is the y value? We know where centroid will lie, somewhere here. So what will be the y value? Plus or minus? Because this y distance need to be measured from what? Centroid, right? So what is the y? Plus or minus? Anyone? It is below your centroid or below neutral axis. It is minus. So what is the minus value? It will be this, which is how much? Minus h. Okay. Now T is uniform, right? T is uniform, so I can take it out. So what will be QS? My QS will be minus Vyt upon Ix integration. Okay, what is the y value we see for section 1 to 2? It is minus Hs. Now I can take minus out. So what we see Vy, and this is ds. Okay, ds. So what we see Vyt, h is also constant, Ix integration ds is what? S. And there will be some integral constant, right? Yes or no? There will be some integral constant C, right? Yes or no? Or you can say QS naught. This is integral constant. Now guys, this at section 1, now how to find this integral constant? To find integral constant, we know what? At s equal to 0, right? At section 1, what is the value of s? You can see your s is varying from 1 to 2. This is the direction. So at section 1, at s equal to 0, qs equal to q1 and it is 0. So we substitute in this equation, what we get? 0 equal to, substitute 0, so plus qs naught. So from here, what is the qs naught? What is the qs naught? Integral constant is 0. So what is shear flow distribution? QS 1 to 2. Your shear flow distribution is what? Vy TH upon Ix into S. Clear? Everyone, is it clear how this distribution come? Vy TH into S upon Ix. So what this distribution? Linear or parabolic? Linear or parabolic? Everyone, please tell me, linear or parabolic? It's a linear distribution. Where it will be maximum? At 2. So if you find QS2, what is the QS2? We know at where to, at point 2, what is the S value? What is the S value? What is the S? S will become H, right? So that means if you substitute S equal to H, what will be QS2? It will be Vy T H square upon Ixx or Ix. So you can see here it is maximum and it is linear. Now guys, we will discuss 2 to 3, like 2 to 3. For section 2 to 3, for section 2 to 3 guys, this is 1, this is 2, this is 3. So 2 to 3, what is the Y value? Can anyone tell? At point 2, what is the Y value? At point 2, what is the Y value? It is minus H. Okay. Then this S is increasing. S is increasing. Okay. So what is the S increasing means? Plus. Okay. So you can see at what is the variation of Y? If you substitute Y at point 2, at point 2, what should be Y? It is minus H. Now if you substitute at 3, what should be Y? Can anyone tell? What should be Y? It should be H. So you substitute minus H plus 2H. So how much we are getting? H. So this will be the variation. Abhijit, it is not H by 2 minus S. It is minus H plus S is what? Variation of Y for section 2 to 3. Everybody, is it clear? Yes or no? Everybody, is it clear? Others, how to take Y value? Is it clear for C section or any kind of this kind of problem? So this. So we need to check upper and lower limit and then some substitute and find out. Yes, Manan, any question? Okay. Now guys, we know Y value and we know what is the shear flow at any section. QS is minus Vy upon Ix integration Ty ds for channel section under Vy load. Now substitute here Y value QS 2 to 3. So when we substitute Y value, what we get? We get minus Vy upon Ix, then T is constant and you can take from here minus outside. So if you take minus outside, it will be integral S minus H into ds. Now if you integrate, what we get? Vy T upon Ix, then it will be S square by 2 minus Hs. Am I correct? Is this integration correct? Then integration constant. Now guys, how to find this integration constant? We know when S equal to 0 for section.
Sir, it cannot be plus, sir.
Huh?
It cannot be plus. You have written as such what is Y. Y is S minus H only, no, sir.
It is minus H plus S, na? Okay, got it. Got. Satish, just a moment. Yeah, I got your point. It is already S minus S here, right? So that means it should be, if you take minus, it will be H minus S. Clear? Now it is correct, na? Now it is correct. H minus S.
Yeah, correct.
Yeah, thank you, Satish, for rectifying. Yeah. So it is minus s square by 2 plus hs and this integral constant. Now how to find integral constant? We know at s equal to 0, this qs 2 to 3 is what? Q2. And what is the Q2? Q2 we already know. What is the value? V by th square by ixx. So V y th square upon ixx, okay, and this equal to what? This will become 0, so it is qs naught. Okay. Yes, Manan. Why negative? It is positive, no? You can see is minus minus plus, no? Why negative? Okay, so we know Q2. Now Q2 substitute in this equation. So QS 2 to 3. What we got? We got Vy T upon Ixx, then Hs minus S square by 2 plus Vy T H square upon Ixx. Now guys, if you substitute in this equation S equal to 2H, if you substitute S equal to 2H, tell me what you guys will get. What you guys will get? You'll get Q3, and what will be Q3? Q3 will be again Vy Th square by Ixx. Guys, please check and tell me, is this correct? So, if you see this equation, tell me it is linear or parabolic? This equation is linear or parabolic? Linear or parabolic? It's a parabolic equation. So that means what? If you draw the distribution, it will be parabolic, and maximum value will be at this. So this is the parabolic, and then again it will be linearly 0. So you can see your shear flow flows like this, and it becomes 0. So if you see, so how the distribution clear now? Yes or no? Anyone has any doubt? Now someone will ask how to do for this part 3 to 4. So 3 to 4 also we can do. Okay, not an issue. So how to do 3 to 4? So C section. Okay, now 3 to 4. So this is 3 to 4. Now guys, can anyone tell for 3 to 4 what will be the y value? What will be the y value for 3 to 4?
Plus H.
Exactly, it will be plus H. So what is the equation? Qs equal to minus Vy upon Ix integral Ty ds. Substitute, so you get Qs 3 to 4 will be minus Vy into H upon Ix, and T also I can take out. So it is integration ds. Now if you integrate, what we get? Minus Vy Th upon Ix s plus Qs naught. Now we need to find Qs naught. So we know again for section 3 to 4, when s equal to 0, what is Qs 3 to 4? It will be Q3. Now Q3, what is the Q3? We know, right, from previous equation, Q2 was equal to Q3. So what is the Q3? It is Vy TH square upon Ixx. Now this will be 0. So your Qs naught is what? This. When I substitute here Qs naught, what is your equation? Qs 3 to 4 will be minus Vy TH S upon Ix plus Vy TH square upon Ixx. Now guys, you can check in this equation, if you substitute S equal to H, what it will be? Q4, and you will see Q4 is coming as 0. Can you guys check Q4 is coming as 0 or not? See, in this equation, if S equal to H, this is negative, this is positive, will get cancelled. So Q4 is coming 0, yes or no, guys? Yes or no? And how I got, guys? You can see how I got Q3. Q3 I will get that from equation QS2 to 3. So everyone, is it clear? The distribution, shear flow distribution, and you can see this equation is what, linear or parabolic? In terms of S, linear or parabolic? So linear or parabolic? It's a linear equation, right? So you guys can see this is linear, and parabolic. Clear? Shear flow distribution clear, guys? How to do? Yes or no? Yes or no, guys? Okay. So once you know shear flow distribution, and we have already assumed in this case my shear center lies on this axis of symmetry and somewhere here. So here we applied this shear force Vy. Okay, and this is shear center. So we know this distribution already. Now guys, to find shear center position, to find shear center position, what first you need? You need first shear flow distribution. Shear flow distribution. Okay. Once you know this shear flow distribution, then you need to take moment equivalence. What I mean by moment equivalence, about any point on section. Moment equivalence. What is the moment equivalence mean? See, this shear force, what is the shear flow? This QS1 to 2, C1, 2, 3, 4. So this QS1 to 2 or QS2 to 3 or QS3 to 4, what it is? See, this shear flow is developed due to why? This developed due to which force? It is developed due to why? It got developed due to what reason? Due to this applied load, right? This shear force. So this shear flow is resultant of what? This. Okay. So that means if you take any point on this section and if you find moment due to this shear force, it will be equal to the moment produced by this shear flow. This shear flows about that point. What I mean, suppose I am taking this point 3. I am taking this point 3, and about this point 3, suppose this distance is E. Okay, this distance is E. So what will be the moment developed? Can anyone tell? What will be the moment developed? It will be Vy into E. Yes or no? Clearly tell me, guys, yes or no? And what is this moment, clockwise or anti-clockwise? Clockwise or anti-clockwise? Clockwise, right? Now guys, if you take this point 3, then what about these shear flows 3 to 4 and 2 to 3? They are passing through this point 3, yes or no? They are passing through this point 3, yes or no? This QS 2 to 3 and QS 3 to 4, they are passing through point 3, means the contribution due to this shear flow and this shear flow, if you take the moment about point 3, what it will be? What will be the contribution due to this shear flow? If you take the moment due to these shear flows about point 3, what it will be? See how we find moment due to shear flow. First, you need to take shear flow, then multiply with a small distance ds. So this will be force. This force into we need momentum. So momentum when it passing through this point 3, what is the momentum? What will be the momentum? See, this is what force, right? And direction is this. So this force, then what is the momentum if it is passing through this point 3? The momentum is 0. So that means this QS2 to 3 and QS3 to 4 will give 0 contribution. But what about 1 to 2? So for 1 to 2, if you see, what will be the force QS 1 to 2? Then length ds. So this shear flow into length gives me force. Then what is the momentum? What is the perpendicular distance? This. Because if you take force, force will be in this direction. So what is the perpendicular distance from 3? What is the perpendicular distance from 3? Anyone? What is the perpendicular distance from 3? Exactly 2h. Now tell me, this force going in this direction, Fs, which is force due to shear flow, into this gives me moment or clockwise or anti-clockwise? Clockwise. So when I say this moment equivalence, that means you have to equate clockwise moment equal to clockwise moment. If your moment is anti-clockwise coming through shear flow, then we'll put minus sign. So this Vy into E about 0.3 is equal to what? It is QS 1 to 2 into ds into 2h. Now guys, we already know what is the QS. What is the QS 1 to 2? Can anyone tell? What is QS 1 to 2? It was what? It was Vy into THS upon IXX, then ds into 2h, and it need to be integrated from what? It need to be integrated from 0 to h. Clear? Because I want what? Force from 1 to 2, right? It is at any section, right? QS is this, QS 1 to 2. So that means it need to be integrated 0 to h if you equate. Because this will be equal to this. It's a moment equivalence. Because this shear flow is resultant of this shear force. So they should be on in the same sense. The moment produced by the shear flow, shear force about any point on section should be in the same sense as shear flow produces the moment. Or like the moment produced by shear flow should be in the same sense the moment produced by shear force at a particular point. So guys, till here, is it clear? Making sense? What I have done? Guys, tell me quickly. Till here, is it making sense? Anyone have any doubt? I'll explain bit further also. See, you are not doing equilibrium, Akshar. It is not equilibrium. Akshat, it is not equilibrium. When you take equilibrium, you equate clockwise equal to anti-clockwise. It is moment equivalence. What is the moment equivalence? Because the shear flow is developing due to that shear force. Then how you can say one is reaction and one is action? It is not like we are equating reaction equal to action. See, this shear flow should have the same sense of moment what shear force we will have about any point. So this is moment equivalence. Is this point clear, Akshat? We are not doing moment equilibrium. We are taking moment equivalence. Okay. So guys, what we found here, what we found, this Vy into E equal to integration Vy THS upon Ix into ds into 2h integration 0 to h. You can see Vy got cancelled. That means your shear center is independent of load, and you can take E equal to outside. What you can take outside? T into 2h square you can take outside. Ix, it is integration 0 to h. It will be what? S ds. So you can say 2h 2th square upon Ix. It will be what? S square by 2, 0 to h. So you can say this 2 will get cancelled. So you'll get th power 4 upon Ix E value. Now E value you got positive. That means what? You got E positive. What it means whatever we consider it is correct. So means your shear center lies on this. Now guys, sometime what in your gate exam they gave coordinate like this. This is origin. Now guys, tell me what is going to happen then. This E will be positive or negative in this case. If this is your coordinate, this is origin they suppose. So what is this E value, positive or negative? It's a negative. So you can say in that case your x will be minus th power 4 upon Ixx. Clear? Okay. Is this point clear? Now guys, someone will say why I should take moment equivalence about 0.3 only. Why should not about point this or this? Yes, you can take moment equivalence about any point on this section, but the easiest is 3. Or you can take also about this symmetry point. What is the advantage if you take through symmetry point? What is the advantage? We can use 2. Symmetry. Symmetry means what? Due to this shear flow and this shear flow, of course the moment arm will be these, but I can write 2, okay, without doing individually. So what we can say, Vy into E will be equal to what? 2 into integration, it will be Vy THS upon Ix ds into what will be moment arm? H, and it will be integration 0 to h. So if you do this or if you do this, your answer is 1 and 7. Okay, clear my point, guys? You can do moment equivalence about this point. So what we did, we just 1 to 2 we took, and then we use the symmetry condition, and we can find using moment equivalence shear center position. Now guys, let's come to gate question, which is there in your gate exam. This is the gate question. Read this gate question and we need to solve this. What it says: the given thin wall section of uniform thickness T is symmetric about x-axis. Moment of inertia is given to be Ixx equal to 35 by 12 th cube. Shear center for this section is located at. Shear center for this section is located at. Okay, so you can see they gave this. See, this is y, this is x. So you know this will be your origin. Okay, so from this origin you have to see x minus, you guys can see what is the position of shear center. So what we are going to do, can anyone tell? 1, 2, then suppose this is 3, 4, 5, 6, 7, 8. So what I am going to do, can anyone tell? What is the first thing which you need to do for this? What first thing in this question, what first thing we need to do? Exactly, calculate shear flow. But for which all section I will calculate shear flow? Akshat. Calculate shear flow, but for which all section? We calculate shear flow for which all section? 1 to 2 and 3 to 4. Very good. Why? We will take now moment equivalence about which point? In this case, what will be the easiest point to take moment equivalence? Manan? 7, huh? Anyone else? 7 means what will happen? You will contribute 1 to 2, 3 to 4 and 5 to 6. So 7 will not be right. 4 or 6? No. The best will be symmetric.
Origin.
Origin, exactly. Why? Because I can use twice, right? I just find 1 to 2 and 3 to 4 and use symmetry. Clear na, Akshat? So let's find 1 to 2. Shear flow for 1 to 2. QS 1 to 2. So what first we need to know, what is the y value? What is the y value? It is minus h. Then QS 1 to 2. What it will be? It will be minus Vy upon, suppose I am considering here my shear center somewhere and Vy is applied. Okay, so it will be what? Minus Vy upon Ix, then integration Ty ds. Now what is the y? Minus h. So substitute. It will become Vy th upon Ix integration ds. So integration ds is nothing but s, then qs naught. What will be the qs naught here? We already know. What will be qs naught? At s equal to 0, your qs naught will become 0, and since it will be q1, so it is 0. So what will be the variation? QS 1 to 2, it will be what? Vy th s upon Ix. Now guys, 1 to 2 we found variation. Let's do 3 to 4. For 3 to 4. For 3 to 4 section, what is the y value? Can anyone tell? What is the y value, Manan? It is minus h by 2. So substitute in this equation QS 3 to 4. So it will be minus Vy upon Ix integration Yt ds. Okay, now substitute this, what we get? Vy th upon 2 ix, then integration ds. Okay, now when we integrate, what we find? Again, Vy th upon 2 ix s plus qs naught. So what will be qs naught, guys, here? When you substitute s equal to 0, your qs naught will be q3, right? I should take here, it was like 1 2 3, here it is wrong marking, so 3 4, then okay, like that. So what it is? q3 is 0, so qs naught is 0. So what will be the variation qs3 to 4? It will be vy t hs by 2 ixx. Everyone, is it clear? This variation 1 to 2 and 3 to 4, yes or no? Anyone has any issue, yes or no? Is it clear, guys? Quickly respond. Everyone, please respond. Yes or no? Yes, Rangarasu, what is the question? Clear? Abhijit, Agam, Akshat, Kiran, Itungo, Sweetie, Ashib. Everyone, please, is it clear? See, now you guys understanding this shear flow stuff, right now? All you are understanding, right? Here you need to have a proper understanding, okay? Then only you can solve this question, thin word question, if question is complicated. But in gate, again, they have given ixx value, right? The half task is done. So now, guys, if you see here, we know now QS34 and QS1 to 2, and we will take moment equivalence about this point, symmetry. So what we will see? Vy into E. Suppose this distance is Ex. Now it will be what? 2. First, don't forget to write 2. Now integration 0 to H QS1 to 2. So what is the QS1 to 2? It is Vy T Hs upon Ix into ds. Into ds. Then what is the momentum? This is H. Now this 1 to 2 will give me what sense? Clockwise or anti-clockwise? See, this is clockwise. You are taking moment equivalence. What it is? Clockwise or anti-clockwise? It is clockwise because you are coming 1 to 2 clockwise. Now, guys, 3 to 4. So 3 to 4, when you go, my shear flow is going in this direction. Now this into ds, shear flow into ds, force. And what is the momentum for 3 to 4? Can anyone tell what is the momentum? What is the momentum? It is length is 0 to h by 2. Momentum is also h by 2. So what it is? It is qs 3 to 4 into, what is the qs 3 to 4? Already we have written. It is vyt hs upon 2ix into ds, and moment arm is h by 2. Now guys, this is going in this direction into this moment arm. What it gives, clockwise or anti-clockwise? See, 3 to 4 you are moving and we got plus, so it gives me what? Moment about this point is clockwise or anti-clockwise? Anti-clockwise, right? So it is anti-clockwise. So what sign here it will come? Here plus or minus? Plus or minus, guys? Plus or minus? Since this moment is anti-clockwise, so it will be minus, because we are not doing moment equilibrium, it is moment equivalence. See, this is clockwise, so this should be equated clockwise to clockwise. So it is clockwise, so we got plus, but since it is anti-clockwise, so here negative side. Now guys, we'll just do integration. So it is Vy into E equal to 2 integration 0 to h. So it is what? Vy ths upon ixx into h. So it become h square ds minus 0 to h by 2 Vy. Then it will be th square upon 4ix into s ds. Am I correct? Is this equation correct? Please guys check. So Vy throughout got cancelled, so it will be 2. Now if you integrate, what we get? th square upon ixx, it's s square by 2, 0 to h, minus again th square upon 4ix. Then if you integrate, it will be s square by 2 and 0 to h by 2. So what we get? 2, then th square by, if you integrate, what you get? th by 4 upon 2ixx, then minus, what we get? th power 4 upon 4, 8, 32 ixx. Am I correct? Is this correct or no? Please guys check, is this correct? We'll get 15 th power 4 upon 16 ixx. Now substitute guys ixx value. What is the ixx value gave? 35 th cube. So when we substitute 15 th power 4 upon 16 into what it is? 35 th power 4 upon 12. So 4. So what answer we get, guys? What we get? This t got cancelled, h cube got cancelled, so 3. So 9 by 28 h. Am I correct? 9 by 28. 9 by 28 h. Is it correct or no? Everyone, please check. Correct? 9/28. Now see guys, we got this E value positive, but it is on what? Negative X, right? It is on negative X direction. So what is your answer? X will be minus 9/28H. Guys, you can say which is my correct answer. Six to five means, see, I will draw shear flow distribution. Okay, how it will be. So is this clear? No, answer is clear. Everyone, please answer. Agam, Kiran, Rangarasu, Jagdish, Kaitya Krishna, Ayush, Anumandla, Ankit, Anish. Please answer. Please respond to poll, guys. Please respond to poll. Please, guys, respond to poll. So, Rangarasu, who took structures for you in that? Haramra 0 or someone else? Rangarasu, when you learnt? Raghunathan. So have he taught all these? Raj Guru Nathanam, sir. Raja Guru Nathanam. Nathan. So these question, all these questions are done, like all the PYQ with all this detail. All PYQ with, no, this question was not done. Okay, others, in non-symmetrical bending, all those questions were done. Is that detail, neutral axis? It just, okay, good. Okay. Fine. So done. Now, Manan, if you see the distribution, how it will be, see, shear flow will flow like this. It will go up. Here it will be added. Then it go. Then it may come out going up like this. Okay. Fine. So now let's do some more question. We'll do. Yeah. This is very good question. Read this question. What it says. The cross section of a long thin-walled member is as shown in the figure. When subjected to pure twist, point A. So guys, first for L section, which is the center of twist? It's subjected to pure twist, and which will be the center of twist? This point A will be center of twist, right? So there is no other load, right? Only twisting. So what will be the movement of A? Will it move in horizontal, vertical, or in axial direction? Since it's a center of twist, it will not move, right? It will be like twisting like this. So all other point other than A will have horizontal and vertical movement. Anyway, there is no axial load, so there is no axial movement. So what is the correct answer? About point A, what is the correct answer?
C.
C is the correct answer. Doesn't move horizontally, vertically, and axially. Okay, so C is the correct answer. So guys, directly this question is related to what? Can anyone tell? Directly this question is related to what? It is related to shear center, right? First you should know the characteristic of shear center, and then you need to know loading. Now in this case, suppose apart from twist, if there is a vertical load, what is going to happen? If there is a transverse load, what is going to happen? A may move horizontally and vertically, right? And it may move also what? It may move also axially also. Okay, because A is not the centroid. Yes or no? See, your bending stress, that means your bending strain only zero at what? Centroid. So if there is a transverse load, okay, apart from this, then what is going to happen? This will move what? All. It will move horizontally, vertically, and so that option is not there. So this question is clear. So let's do a poll. Yeah. A is the answer. Vertically it will move, Mr. Rangarasu. Will it move vertically? Yeah? In this case, it will not move anywhere. So C is the answer. Let's see the next question. What it is given. Oh, that was the point of twist. Okay. Shear center. Fine. So read this question. What it says. Which of the following statements is or are true about shear center of cross section P? It is that point in the cross section through which shear loads produces no twist. Yes. This point is the also center of twist of the section subjected to Q torsion. Yes. The normal stress at this point is always zero. No. So what is the correct answer? So P is correct, Q is correct. So P and Q. C is the answer. C is the answer. C is the answer. C is the answer. C is the C is the answer. Rahul. What is the answer? Rahul Praveen. Kiran K. Pithungo. Niguli. Next question. Read the question what it says. Which of the following statement about the neutral axis of a beam with unsymmetrical cross section is true. So the product of second moment of area about neutral axis is always 0. No. What is the product of second moment of inertia? It is not 0, right? The normal stress along neutral axis is always 0. Yes. The shear stress along neutral axis always 0. No. The product of second moment of area about neutral axis and normal stress about neutral axis are always 0. No. This part is correct, but this is wrong. So what is the correct answer? B alone is the correct answer. B alone is the correct answer. Next question.
Sir, in the previous question, no, you explained, sir, why other options are not fitting.
This product moment of second moment of area. This question, right?
Yes, sir.
See, we know, right? When we took resultant, right? Stress resultant. So what we see? The first moment of area. Integration y dA we got 0 about neutral axis, right? Did you receive this integration y square dA is 0 about neutral axis? No, right? This integration y square dA is what? Represent what? Moment, right? Moment resultant we got now, right? See what we found. If you remember, we find first sigma into dA is force into momentum. This was moment, right? So what is sigma? It is k kappa times y, right? So it is y square dA, right? So this is not 0, right? About neutral axis. So this is it getting point?
Yeah, okay.
Okay, na? But we know, right? Sigma dA, right? If you integrate, right, that will be integration, right? So sigma dA should be what? Force. And we know there is no force in axial direction, right? In case of bending, what is the sigma? It is E will be also there, right? So it was E K y square, right? So it is now what? E K y. So it is what? E K I can take out. So integration y dA, right? Now this is 0. So what we got? Integration y dA is 0. So first moment of area is 0 about neutral axis. Is it clear?
Yeah.
Yeah, fine. So let's move ahead. See this question. Now what is given this question? A wing root cross section is idealized using lumped area as shown below. Lumped area as shown below. Now guys, to solve this question, first you need to understand how the aircraft is idealized. So you guys need know this aircraft is idealized like this. There are two wings and this is fuselage. So entire weight of aircraft where it acts, will it act on wing? Will it act on wing? The entire weight of the aircraft where it acts, it will be acting here, right? So what will be lift? It will be L by 2 and it is L by 2. You guys are understanding? This is the idealization. Now guys, we know steady level condition L by W is what? 1. Okay. So what we see, L by W is 1, right? In study level condition. So they talk wing root section. So this is only about one section, one wing and root section. So what will be the moment in study level condition at wing root? What will be the moment? Wing root moment will be what? It will be lift L by 2 into some distance, which is suppose distance x, right? And they given initially, what is the moment? They given in study level condition, this moment is 10. Now guys, what happened when you have factor, right? N equal to 3.5. So what will be lift? What will be the lift? It will be 3.5 times of initial, yes or no? New lift, right? If the weight remains same, so what increases in maneuvering? You increase your lift or decrease, right? Will weight going to change in maneuvering? Guys, answer. It will not change. So it will become initially of 3.5 times. So what will be the new moment about root? It will also become 3.5 times of initial. So initially how much? It is 3.5 times. So it will become 35 Newton meter. Now guys, moment is known. Okay, and this given section is given. What is asked? What is the maximum bending stress? Okay, what is asked? Maximum bending stress. So we know sigma, it will be how much? It will be mr in maneuvering, okay, upon I, okay. So my is given, so it will be iy, and it is what I think z distance, okay. So guys, what is the important? You need to find Iy. Now guys, what will be the Iy? Iy for boom, it will be what? Sigma A Z square. Or you can say it will be sigma A Zi minus Z bar square. Now guys, here your centroid is here. So Z bar, if I take reference itself is this. So Z bar is 0, only Zi distances. Now Zi distances will be what? Plus minus. So what will be your Iy? You can say it will be 4, area is given. It is 1 centimeter. So you can convert to meter. So it will be 10 to the power minus 4. Am I correct? Centimeter square in meter 10 to the power minus 4, then z distances is how much? 0.025 square. So you know this is what Iy. Now what will be the sigma? So my sigma will be 35 upon Iy is how much? 4 into 10 to the power minus 4, 0.025 square into, what is the z? It is 0.025, because it's a, guys, it's a symmetric section. It is a symmetric section. So we know for symmetric section, and my alone is applied. So if you see the distribution and my given positive, so that means what? It will have like on top it will be tension and bottom it will be compression like this. So that means maximum will be either on top or bottom. So what will be the z distance? It will be 0.025. Guys, please find the answer. So what is the answer? A or B? A is not correct. Just check it. I think B is the correct answer. structure.
Yeah, B option, sir. Okay.
Yeah, B is the correct answer. So from here, we see the answer will be 3.5 into 10 to the power 6 Newton per meter square. Now guys, Rangarasu, have you done this question earlier? This question? See guys, in this question, what mistake people do? Anyone can tell what mistake people do? They consider
Considering
usually this wing section and the weight is acting here and lift is acting here like this. Is this correct idealization? Is this correct, Ashish? Is this correct? No. This weight is not the weight of the aircraft. What this weight? Eh? It is wing plus fuel weight, right? But when you see such questions, you have to put your entire weight on the centroid of aircraft and then solve this question. If you do this, you can't solve this question. Okay, everyone. So what is the answer? Yes, guys, please answer. Sweetie, Rahul, Kiran, Anish. Rahul, Kiran, Anu, Mandala, Anish, please answer quickly. Okay, let's move to next question. Yeah, so this is one of the very good question, guys. Okay, and here no calculation, no formula will be applicable. Read this question. To solve this question, guys, frankly, no formula will be applicable. Okay, so should I solve this completely or explain the steps? It's already late actually, that's why I'm asking. Should I solve this question or just explain the steps? Have you done this, Rangarasu, this question? This question is based on what? Again, equivalence. Have you solved this question, anyone? No formula is required this question. It's only equivalence. Have you solved, Rangarasu? Are you there? Solve this. Did you solve this question? Okay, no problem. We will solve. So read this question, what it says. See, this is one of the old question. It has come in very old paper, but one of the best question. And you can say, if you know, understand structures, you can solve. So what it is given, you read this question, what it says. An idealized thin-walled two-cell symmetric box beam as shown. The shear flow in the walls are due to applied shear forces Vy and Vz and torque M. So what it means? All acting on shear center. So first place, what will be the shear center? It's a symmetric section. So this will be shear center. All you agree? Now this, whatever shear flows developed, are these developed due to what all action? Due to Vy, Vz and Mz. So these shear flows are what? Combined effect, right? These are what? Combined effect. Yes or no? Everyone understanding what I mean by combined? Whatever you say, na, this 22. This 22 is not just due to like either, Vy or Mz. It's a combined effect. Okay, it's a combined effect. So To solve these questions, what you have to do, simply first find out what is the sigma Vy, what is the sigma Vz. This sigma Vy will be nothing but what? It will be applied horizontal force, which will be Vy, and sigma Vz will be what? It will be equal to 300. And if you take moment equivalence about this point, or you can take a moment equivalence of all these applied about this point. Okay, so that will be equal to what? Your applied torque. Okay, if you take the torque or moment about this point or shear center due to all these, okay, it will be equal to what? Mz. Now how to take sigma Vy and sigma Vz, I'll tell. So this is 300 and this is 480. Now guys, how you take sigma Vy? See, this is positive y direction. Now shear flow, will this vertical shear flow gives force in horizontal direction? Will this vertical shear flow gives force in horizontal direction? Quickly guys, yes or no? Vertical shear flow will give force in horizontal direction? Will vertical shear flow will not give any force in horizontal direction. Why? Because this is the direction, right? If you multiply qs into ds, my direction will be downward, not in horizontal. So horizontal forces are what? You take this 22. So 22, what is the length? 12. It is going in positive y direction plus. Then again 22. What is the length? 12. Then this 2, it is going in negative y direction, so it is minus 2 into 12. Then this q1, it is going in what? Positive direction, so plus q1 into what is the length? 12. This should be equal to what? Since it's a force equivalence, so this is equal to what? How much? 480. So what is the q1 guys? What is the q1? It's minus 2. Now this is what we have done, sigma Vy equal to Vy. Now do sigma Fz, or you can say sigma Fy we have done. So sigma Fz is equal to what? Vz. What is the sigma Fz? Vertical direction. Now you take this shear flow, it is going downward and positive is upward. So what it is? Minus 2 into 10. The middle one, it is going upward, so it is plus 10 into how much? 10. Now the last one, which is going again upward, q2 into 10, and this is equal to how much? 300. So what is the q2 guys? What is q2? What is q2? Exactly, 22. So what is the answer for question number 8? Guys, quickly answer. What is the answer? Okay. So let's see next question, question number 9. So in 9, they ask this torque, which is unknown, right? The applied torque is unknown. So we know where torque is applied. Torque is applied at the center of twist. What is the center of twist? Is shear center. Now if you find the moment equivalence about this shear center, this will be nothing but applied torque. Now I have taken my applied torque in anti-clockwise direction. So I have to equate all those which create anti-clockwise. So this 2. So 2 into what is the momentum? So first 2 into length. Length is how much? 10. What is the momentum? 12. And it gives me what? It will give me anti-clockwise. Then 22. What is the length? 12. What is the momentum? It will be 5 because this is the 5. Now again this 22, 12, momentum 5. Now what about this Q2 going upward and we got positive. So it is 22 into 10. What is the momentum? 12. And it is again give me anti-clockwise. Then 2. The moment length 12, momentum 5. It is N. Now what about Q1? It is going in this direction, but we got minus. So this means anti-clockwise. So minus into minus 2, length is 12, momentum is 5. The middle will not give any. So tell me the value of M. So this, the torque, so whatever the torque produced by these shear flows will be equal to what? Applied torque. Anyone if having doubt, let me know. In this understanding the direction, you can see all the torque are giving me anti-clockwise, all the shear flow producing anti-clockwise torque. Means the torque in x direction. So what is the answer, guys? What is the answer? What is the answer, guys? What is the answer? Five, 7, 6, 0, and it will be Newton centimeter, right? So what is the answer? Now tell me, guys, was this tough question? Was this tough question? If we understand what we mean by moment equivalence, force equivalence. So guys, try to understand whatever these shear flows, these are developed by applied loads only. Okay. So they should be equated. They should not have equilibrium between them. Okay. I think B is the answer. B is the answer. Everyone please answer. B is the answer. Everyone please check. I think it is not that tough calculation. Only the number of terms are more. Please guys check. First term, second term, third term, fourth term, fifth term, sixth, chair term. The middle will not produce anything. Okay. So I think done from my side this topic. Then a small topic is still pending. So that I have to check. I think all these are done. So fine guys, done. So we have discussed by this all the thin wall concepts. Now one small topic is there. So I'll do it accordingly whenever it is possible. Okay. I am not available on till Monday. Mostly on Tuesday or sometime Wednesday. I'll do it. Okay. Fine. All right. It's okay. Yes or no, guys? So next Wednesday, let me see. Yes, I can do, and then some more things I'll do. I will discuss some more thing. Yeah, that day. Some compatibility equation and Airy stress function also I will discuss that day. Clear now? So now two things are there: compatibility equations, Airy stress function, and some small topics. So that I will complete. So anyone has any doubt in concepts, questions, or anything? Whatever I have discussed. Anyone has any doubt? So Wednesday I'll be taking one class, and then after that I need to take one or two class for one class around for vibration also for you guys. So that also I'll take. Okay, and space also. So there are things which we need to do. I think 3-4 classes from my side I need to take up. Okay, we'll take up. Yes, Rangarasu, tell me. So first mock exams will be around on 7th. First mock exam from IGC will be on 7th, Saturday, Jan 7th. Clear to everyone? First full length mock exam. Yeah, it will be live exam, na? Like 2:30 to 5:30. Same gate slot. We will be taking 10 to 12 mock exams. So the first one will be on Jan 7th. So guys, plan revision accordingly. First mock exam. Yeah, Ashish, we can have, but first let us complete syllabus, no? We will have on in January first week. Before exam we'll have. Okay. But first idea is to complete whole syllabus, 100% syllabus. Okay. Because it's still vibration and space dynamics part is there, right? I think remaining all done. Vibration Sunday we are starting. So Sunday, Tuesday, Thursday, and then mostly by Saturday, Sunday we'll finish it. Okay, bye. Bye
When
guys,
is the
good night.
propulsion class, sir, again?
Huh?
Propulsion class, when is it again?
Tomorrow is there, na?
6 o'clock, huh?
6 o'clock. Is it fine now, Satish, for you?
Yeah, sir. It's okay. Because today also I could not attend actually. It's okay.
But you can revisit, na, recording.
Yeah.
Yeah, because now time is not there, na? Because see, we have to conduct full-length mock exams also. I am okay to conduct classes till mid of Jan, but it will not be good. What you say?
Yeah, correct, sir. It's okay.
Yeah.
Okay.
You can watch recording early morning, or you plan in office also. Mobile is not allowed, right? So you plan
Yeah.
accordingly. Yeah.
Okay.
Okay. Thank you guys. Bye.